Hey, good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra class. Today we're going to continue with our discussion on linear equations, and we're going to expand it and start learning about how to write and recognize parallel and perpendicular lines, okay? So it's extremely important, and this is going to use all of the knowledge that we have learned so far. Okay, so for parallel and perpendicular lines, okay, I'm going to first briefly review all of the forms of linear equations that we have learned thus far. You have the slope-intercept form, which is y equals mx plus b. Y is the dependent value. X is the independent value. What is m? That's my slope. Remember that slope equals rise over run if it's positive, or fall over run if it's negative. Remember that we always run to the right. What is my b? That's the y-intercept. That's the y value on the y-axis when x equals 0. We have the points. Before we go to points of form, what is the best use for the slope-intercept form? When is that the best time to use the slope-intercept form? We went over this. When you graph, you don't plot points when you use the slope-intercept form. You graph the y-intercept and then you follow the slope from there. We don't plot points anymore because we have more advanced skills. Next, point-slope form. Point-slope form is best used for? No. It's for writing linear equations. That is the best use for point-slope form because they give you a point and a slope. y1 and x1, that is the given point. M is the slope, okay? And then we have standard form, which is ax plus by equals c. And what is that best used for? Thank you very much, sir, for finding the intercepts. Very good. Okay? But remember, A and B have to be in what form? A and B must be integers. Very good. Thank you. You don't want fractions or decimals at all. Now, parallel and perpendicular lines. When we're talking about parallel lines, this is something you have to remember, okay? I'm a little bit worried because all the questions I asked in the first page, not many of you could answer. So that tells me you're not studying. That tells me you're not studying. And if you guys don't study, it gets very difficult to progress. But parallel lines, etch this in your memory, my friends, have equal slopes. Okay? They have equal slopes, but different y-intercepts. Equal slopes, but different y-intercepts. If they had the same slope and the same y-intercept, then that means they would be the same line, exactly. But if you have, for example, this right here, y equals 3x plus 8, and y equals 3x minus 4. The slope is 3. The slope is 3. So that means that they are parallel. Whenever you have equations that have the same slope but different y-intercepts, they will never intersect, but for sure remember that they have the same exact slope. Okay? Perpendicular lines. Perpendicular lines are lines that intersect to create this little box, and that little box represents 90-degree angles. So perpendicular lines are lines that intersect where they form 4 right angles. Because if that's a right angle, then that's a right angle, and that's a right angle, and that's a right angle. Okay? Now, the slopes of perpendicular lines are negative reciprocals of each other. What's a reciprocal, my friends? Sir? It's when you flip a number. It doesn't even have to be a fraction, my man, but very good. When you flip, remember state change flip for division? The flip part, that's how you form a reciprocal. So for perpendicular lines, the way to recognize it is looking at the slopes and see if they're negative reciprocals of each other. So you have y equals negative 1/3 x. My slope is negative 1/3. And I have y equals 3x. My slope is m. Negative 1/3 and 3, they are negative reciprocals. How? How do you know, Mr. Morrow? How do you find this out? Very simple. If I have the original slope here, and then I have my negative reciprocal, how would you think I go from, let's say I have, for example here, negative 1/3. How do I make that a negative reciprocal? Yes, sir. You flip it? Very good. So technically what my boy did there was you multiply by a negative 1 and you flip it. So what's negative 1 times negative 1/3? And then flip it, that goes to 3. If I had a slope of 5/2, what is a negative reciprocal of 5/2? Negative 2/5. If I have an original slope of 4, what is a negative reciprocal of 4? Negative 1/4. So if you know how to recognize negative reciprocals, you will be able to tell that, hey, wait a second, negative reciprocals, all these lines have to be perpendicular. Does that make sense so far? Thank you. So how to write equations for lines that are parallel or perpendicular. I'm going to give you the rules for either or, okay, because it's the same rules. Okay, so how to write an equation for lines that are parallel or perpendicular to a given line, a linear equation, or graph going through a particular ordered pair, x1, y1. Remember, oh, what was that? x1, y1, that is the point that is given. So, number 1. Oh, sorry about that. Number 1, find the original slope of the given equation. My friends, sometimes they'll give it to you in a nice, easy way. For example, they can tell you, okay, find an equation that's parallel to this. Well, that's pretty easy. The slope is 3 there. Very simple. But sometimes they're going to give it to you like this. Negative 3x plus 2y equals 4. What would I have to do in this second situation in order to find my slope? Sir, you have to solve for y. Very good. So you would add 3x to both sides. So I got 2y equals 3x plus 4, divide by 2, and then y would equal 3/2 x plus 2, and that would be my slope. So they're not always going to give it to you, boom, easy. Sometimes they may give you a line, okay? For example, they could maybe give you something like this, y'all. Check this out. I could easily give you this. Easily. Okay, let me go ahead and make this a little bit nicer. And boom. Okay, perfect. I could say, write an equation that is parallel to this. Oh my God, how do I find slope here? Perfect points. Here's a perfect point. Here's a perfect point. I went down 1, 2, 3, 4 over 1, 2, 3. My slope would then be negative 4/3. So please remember how to find slope, whether it be in an equation or on a graph, please. Yes, sir. The question is, if they ask you to write an equation for it, will we have to graph it? Sure, why not? It's just as easy to graph that equation as the other one. So number 1, find the original slope. Number 2, find the parallel, okay, or perpendicular slope. Why do I say or? It depends on the question, gentlemen. and ladies out there in the internet world, it depends on the question. If I say to you, write an equation that is parallel to the given line, then I'm looking for the parallel slope. And remember, parallel slopes are equal. So it would be the same slope. If I ask you for a perpendicular line, then I have to look at my original slope and find the negative reciprocal of it. So step 1, find the original slope. Step 2, find the parallel or perpendicular slope, depending on what you're looking for. Number 3, this is the easy part now. We have all done this. We know how to write an equation once we have a given point and a slope. So you plug in the given point, x1, y1. They will always give you enough information so you have at least one point. And the new parallel or perpendicular slope into point slope form. Remember point slope form, we just went over it, is y minus y1 equals m times x minus x1. Step 4, solve for y into slope intercept form, y equals mx plus b, and guess what? You are done. So if anyone out there has really been paying attention so far, you should be thinking to yourself, wait a second, Mr. Morrow, this is exactly the same as writing an equation when they give you a slope and a point, except you got to just look at what slope you're going to use. If you made that connection, you are on your way to success. If you didn't make that connection, I'm making it for you now. Please realize what I just finished saying. This is the same as writing an equation in point slope form, except you have to decide what slope you're going to use. May I continue to some examples? Okay. All right, here we go. Remember, guys, there is a video. So if you cannot keep up in class, you can watch the video. And you can hit pause, rewind, fast forward, and you can cater it to the speed that you need. Please remember that. Okay, that was okay. Now, here we go. Write an equation of each line in slope-intercept form, which is A, which is parallel to this equation, and it's passing through this point. You know that I am a huge labeler. I love to label things. That's why I do well in math. So the point they gave me, that's my x1, y1. So in the steps we just looked at, what is step 1? Thank you very much. The original slope in this case is 6. Thank you. So what is my step 2, gentlemen? Go ahead. Don't be shy. Say it out loud, my man. Don't be shy. Well, my boy just said is find the parallel or perpendicular slope of the given equation, depending on what we're looking for. Are we looking for the parallel slope or perpendicular? So what is my, look at the symbol I use. This is parallel, and this is perpendicular, okay? So I use my parallel slope. What's my parallel slope going to be in this case? 6. Now what's step 3, my friends? What's step 3? We just went over this. Thank you. Thank you very much, sir. Plug it into point slope form. Y minus y1. So remember, that's minus a negative 3. So minus a negative 3 becomes plus 3 equals m. What's my slope that I'm using? I'm using the parallel slope times x minus x1. Y plus 3 equals 6x minus 6. Subtract 3 to both sides. Y equals 6x minus 9. That is my parallel equation. Be honest. Is that tough? Now, you guys say no to me now. Is it going to be tough if you don't go home and practice it? Yes, because you're going to get confused because you're a human being. Human beings make mistakes. That's why we learn and practice. Yes, sir. That, that's it. I'm not trying to be sarcastic, but what else do you want? This is the parallel equation. Okay, how do you know this parallel? Are the slopes the same? Are the y-intercepts different? Then you're golden. Talk to me. You look confused.
No, I have it. I just thought we had to do like in step.
No, that's it, my man. I did my point slope form and my step 4. Sorry, maybe I should have numbered it. I apologize. Step 4 is solve for y into y equals mx plus b. Thank you, sir. That's the answer. Okay, guys, why are we confusing things now? Write the equation of each line in slope-intercept form for A, which is parallel to this and passing through that. Didn't we go through all 4 steps to come up with the parallel equation? Thank you. Does everyone understand this? Okay. Thank you very much for your honesty. Number 2. Now I want a line that is perpendicular. What's my first step? Thank you. Original slope. What's my original slope, y'all? -4. Second step. In this case, we're looking for perpendicular slope. What's the perpendicular slope? 1/4, because it's a negative reciprocal. Multiply the original by a -1 and flip it. Step 3. Point slope form. Y minus y1 equals m times x minus x1. Step 4. Solve for y. Y minus 5. Please remember to distribute. Equals 1/4 x minus 2. Add 5 to both sides. Y equals 1/4 x plus 3. That is my perpendicular equation to the equation that they gave me up here going through this point. Because that is my x1 and that's my y1. Does everyone see this? Yes, sir. I got 1/4 because it's a negative reciprocal. To get a negative reciprocal, you multiply by a -1 and then you flip. Thank you, sir. Sir. That is the only difference between parallel and perpendicular. It's the slope. Yes, sir. Parallel lines have equal slopes, my man, and perpendicular lines have slopes that are negative reciprocals of each other. Does that make sense? Okay. Let us continue then. Write an equation of each line in slope-intercept form, which is parallel to y equals 2x plus 3, passing through the point -3, -1. Step 1. Original slope. Notice how I label this, guys. I'm 40 years old. I have been doing math, oh boys, I don't know, for over 30 years. Okay? I've been teaching math for over 17 years. I still go step by step. And that's not because I'm so awesome. It's because I'm so not awesome. It's because I make mistakes. And if I, who have been teaching for this long, make mistakes, with all due respect, don't you think that you guys should follow my rules so that you make less mistakes? So label, 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 label. Step 1, original slope. Step 2, in this case, thank you, my man. Find the parallel slope. What's the parallel slope in this case? Wrong. It's parallel. 2. Parallel lines have equal slopes. Step 3. Plug into point slope form. Y minus y1, so that's plus 1, equals m times x minus x1, so that's plus 3. Step 4. Solve for y. Y plus 1 equals 2x plus 6. Thank you. You distributed. Well done, sir. Subtract the 1. Y equals 2x plus 5. That is my parallel line. Yes, sir. No, for the quiz, you don't have to put parallel. I will know it's parallel. I'm just trying to teach you, and I want to make sure that you guys understand that that is the finality. That is the end. That is what we are looking for, sir. Thank you, sir. Okay, next. I want you to find the equation of a line that is perpendicular to y equals 2/3 x minus 1 and going through 12.5. Step 1. Thank you. Original slope, which is step 2. In this case, perpendicular slope. Excellent. -3/2. Fantastic. Number 3. Plug it into point slope. Thank you. Y minus y1 equals m times x minus x1. Step 4. Solve for y. Y minus 5 equals, gotta distribute. So this is -3 halves x. Now, what's -3 times -12? Positive 36 divided by 2. Okay, guys, -3 times -12 is 36. Divided by 2 is not 12. It's 18. Add 5 to both sides. Y equals -3 halves x plus 23. That is my perpendicular line. Does that make sense, gentlemen? You promise? Okay. Talk to me, boys. I see some of you out there looking confused. That's normal. Ask questions, though. That's what I'm here for. That is my job and my responsibility and my pleasure. Sir, you could graph that, but I wouldn't make you graph this with such a high y-intercept. But, I mean, you could, right? Real quick, whatever. Let's say that's my y-intercept of 23. Don't you go down 3 over 2, right? And then down 3 over 2, right? And you just keep going down like that forever, right? You with me, sir? Okay. May I continue? Thank you. Determine if the given equations are parallel, perpendicular, or neither. So what do you think you have to compare here? The slope. Very good. So in this case, for A, I'm going to solve for y to find the slope. This is y equals -5/4 x plus 3. So this slope is -5/4. This slope is 4/5. Are those parallel, perpendicular, or neither? Perpendicular because it's the negative reciprocal. Very good. Number B, or letter B, solve for y. So subtract 4x to both sides. -3y equals -4x plus 9. Divide by -3 to everything. Y equals 4/3 x plus 3. This slope is 3/4. This slope is 4/3. Are they parallel, perpendicular, or neither? How are they parallel if parallel slopes are equal? And they're neither because they are reciprocals of each other. Very good, son, but they're not negative reciprocals. So this would be neither. Next, solve for y. Subtract, divide by 6 to both sides. Y equals -1x over 6 plus 1. My slope here is -1/6. My slope here is -1/6. So this would be parallel because they have equal slopes. Yes, sir. Of course it's easy. Guys, let me give you a hint. And everyone out there in the internet world as well. Let me give you one piece of advice. Anything that you put your mind to is easy. Anything that you put your mind to is easy. Mr. Moore, what about nuclear engineering? Well, a good example. I can put my mind to nuclear engineering. It's not going to be easy, but you know what will be easy? Knowing that I put my mind to it and realizing, hey, this is a little too advanced for me. Anything, guys, within reason is easy if you put your mind to it. So thank you for saying that. This is easy. Good job. All right, now, Let me give you a little bit more of a complicated one. I want you to find a parallel and perpendicular equation to, let's say, 4x minus 3y equals 6, comma, going through, I don't know, let's say negative 4 comma 5. Okay, let's first do our parallel equation in blue. Okay, what's step 1? Yeah, find the original slope, but wait a second. The slope isn't given to me yet. What do I have to do first? Thank you very much. Subtract the 4x to both sides. Very good. I got negative 3y equals negative 4x plus 6. Now, thank you. Divide by the negative 3. Excellent job, gentlemen. So y equals 4/3 x minus 2. So again, what's my original slope? 4/3. I'm looking for a parallel line in this first one. So what's my parallel slope? 4/3. Now I plug it into the point slope form. Y minus y1 equals m times x minus x1. Does everyone see that? Now, we got to solve, and I did this on purpose. I did it ugly because you've got to know how to work with ugly numbers. This is y minus 5 equals 4/3 x, because I distribute, plus 16/3, because 4 times 4 is 16, and 3 times 1 is 3, so that's 16/3. Everyone with me there? How do I solve for y? That's exactly right. You add 5 to both sides. So y equals 4/3 x plus. How do I add this 16/3 and this 5 over 1? Common denominator. Common denominator is going to be 3. So this is 16/3 plus 15/3, which equals 31/3. That is my parallel equation. Talk to me. I know we're going to do the perpendicular now, but talk to me here for parallel. Sir, could you turn the 31 over 3 into 10 and 1/3? Yes. But do not turn the slope ever into a mixed number. Ever. Sure. I wouldn't turn the 16 over 3 into a mixed number. It's easier if you just leave it in fractions. You can. The answer is yes. But I wouldn't. May I continue, guys? Okay. I'm going to erase this now. And I'm going to put the perpendicular information in red. Okay? Oh, I shouldn't have done that. What was my original slope again? Do you guys remember? Okay, thank you, my friends. So the original slope was 4/3. We already figured that out. My perpendicular slope? Yes. Now, y minus y1 equals m times x minus x1. So minus a negative 4 is plus 4. Very good. So now step 4, solve. Y minus 5 equals negative 3/4 x. What's negative 3 times 4? No, not 3. Negative 12 divided by 4 is negative 3. Add 5 to both sides. So y equals negative 3/4 x plus 2. That is my perpendicular line. Does everyone understand this? Any questions at all that I would be more than happy to help or answer? Thank you very much. All it is using the point slope format, but figuring out what slope to use. Yes, sir. Yes, sir. Question.
Can you graph these?
Of course you can graph these. Let's graph it real quick. Good suggestion. So I could show you what parallel and perpendicular look like. Okay, so let's see here. My original slope, I'll do in green, since I wrote it in green. My original equation, that's going to be y equals 4/3 x minus 2. So y-intercept is negative 2, up 1, 2, 3, 4 over 1, 2, 3. Up 1, 2, 3, 4 over 1, 2, 3. Down 1, 2, 3, 4 over 1, 2, 3. That is my original line. Come again? Why is it minus 2? Because I solved for y here, son. Okay? Now, my perpendicular line will be in red. Y-intercept is 2. My slope, down 1, 2, 3 over 1, 2, 3, 4. Down 1, 2, 3 over 1, 2, 3, 4. Backwards, 1, 2, 3 over 1, 2, 3, 4 to the left. Connect the dots. And guys, I promise you, since these are negative reciprocal slopes, you just created a 90-degree angle. Thank you very much. Hope you learned a lot and have a wonderful day. Homework is valid. Do it, please. But remember, we're behind. So make sure you do the homework that is for 4-9. Not tonight's homework, but the 4-9 homework. Thank you.